right, so just 3 chapters left. Chapter 6, which is a long chapter, and then 8 and 9. 9's short, 8's medium. 6, a lot of 6 is an exact duplication of intermediate algebra. If you took me for intermediate algebra, I cut and paste a bunch of problems from my intermediate algebra homework into this homework, so there's going to be a lot of overlap. So hopefully you haven't completely forgot intermediate algebra, that a lot of this chapter is friendly. The first problem in section 6.1, we already did composition of functions. This f of g of x, it means find f of g of x, and that might not mean anything to you unless you were a math teacher, because those symbols might be equally confusing. What this means to do, this means to replace the x in the f of x function with 5x minus 7, which is the g function, or the right side of the g function, and simplify. So to do part A, f composed with g of x, I'm going to write f without the x, leave a parentheses where the x was, so f was 4x minus 5, put a parentheses where the x was. Inside the parentheses, I put the right side of the g function, and then I just simplify. And this shouldn't be that hard to simplify. There aren't any fractions to deal with. There's going to be no factoring because there's no squares. It's just a pretty clean simplifying. I clear the parentheses. I get 4 times 5x, which is 20x, 4 times minus 7, which is 28, minus 28. I'm going to combine the minus 28 and the minus 5 into a minus 33, and I'm going to write my answer. You don't necessarily have to write the original problem with the answer, but it's not such a bad thing to do either. I'm going to write f composed with g of x equals, and then it's going to be 20x minus 33. The wrong thing to do, it would be an error or wrong, if you took that answer, 20x minus 33, and you set it equal to 0, and if you wrote in your answer x equals 33 over 20, or x equal to anything, that would be completely wrong to do. So to do a composition of a function, it's not asking me to find some polynomial, then set it equal to 0. You find, in this case, a polynomial, and you stop. So for part A, that's everything there is to do for part A. And then for part B, finding the domain of f composed with g of x, because there aren't any square roots, so because there's no square roots in f, g, or the answer, and no fractions, there's going to be no algebra for the domain. These are just polynomials. F, g, and f composed with g are all polynomials, so there's no algebra for the domain. And that's going to be the case for the first few examples that I do in section 6.1. So when I go to write the domain, the answer for it, the domain of f composed with g of x, I can write the words all real numbers if I want to, or I could write the interval equivalent of that, and that's the interval from negative to positive infinity. That would be fine. Equivalently, if you wrote the words all real numbers for the domain, that would be equivalently correct. And in my instructions, I don't ask for a specific way to write the domain, so I couldn't give you points for one as opposed to another. They're both equally correct. There are other ways to write the domain as well that are correct. So if you came up with an answer to part B for the domain of this, and your answer looks different than one of these, if you just send me an email or come visit me and tell me what your answer is, I can tell you if it's equivalently correct, because there could be something like this: the set of all x such that x is an element of R That would also be a correct answer. It would be nothing like I've shown this semester, but maybe something you remember from your intermediate algebra class, or if you took college algebra, this is your second time taking it, maybe that is something you decided to come up with. That's equivalently correct. All of these mean there aren't any numbers that I can plug in and get undefined or an I, essentially. 2 is the reverse. 2 wants me to find, part C of number 2 is the reverse. It wants me to find g composed with f of x. And for what that's worth, not that this is probably infinitely better, but this means to find g of f of x. And in words, this means to replace the x in the g function, in the right side of the g function technically, but I'll just say in the g function, with 4x minus 5, which is the right side of the f function, and then simplify. And so I'm going to write, my algebra is going to go like g composed with f of x equals, I write the g function without the x, leave a parentheses where the x was. Inside the parentheses, I write the right side of the f function, which is 4x minus 5. Now I'm just going to simplify. Again, there aren't going to be any exponents, so I'm not going to have the need to factor. And I'm not going to get a numerical answer. I'm not going to simplify and set this equal to 0 and write x equal to something. So my answer, and I'll go ahead and write the problem with the answer again. I'm going to say g composed with f of x equals, I'm going to leave the 20x, and I'm going to combine the minus 25 and the minus 7. Those are both negative, so I'll add them and keep them negative. If you did any more than this, well, I take that back. One thing more you can do that would be okay, so you could factor out a common factor of a 2. If in your answer you wrote 2 times 10x minus 11, that's probably even a better answer than what I have written. I didn't realize a factoring was going to happen. This kind of factoring out common factors, I probably, if you miss it, I wouldn't take points off. But if there was a square when I found g composed with f of x and a trinomial that factored, you should go ahead and factor it. Part D wants me to find the domain of this answer. Again, because f, g, and the answer g composed with f are all polynomials that have domains of all real numbers, the domain answer for part D is also going to be all real numbers. For me, it's quickest to write the interval form of all real numbers, the interval from negative infinity to infinity. But if you wrote the words all real numbers, that's equivalently correct. Or if you wrote something that also means all real numbers, that would be correct. So you don't need to show multiple answers here. Just something that means negative to positive infinity would be completely adequate. D, or 4, I don't see any fractions or square roots, so when I get to the domain part, there's not going to be any algebra, because f is a polynomial, g is a polynomial, f composed with g of x is going to be a polynomial, and the domains of polynomials don't require any algebra, they're all real numbers. So when I get to this part, there's not going to be any algebra. In this part, there's the potential that I need factoring because I have a square going on. To do part A, to find f composed with g of x, I write the f function, which is x squared plus 2. I write it without the x. I leave a parentheses where the x was, and I replace the x with 5x minus 1. So since the f is written first, I write the f function without the x, leave a parentheses where that x was. Inside that parentheses, I write the function that's written second, which is g. So I'm going to have f composed with g of x equals that. I don't think that that's going to ultimately factor when I simplify this, but I should definitely simplify this a bit. This is the kind of simplifying where if you don't write out that 5x minus 1 squared means 5x minus 1 times 5x minus 1, that you might miss the foiling and simplify this wrong. So now I'm going to write f composed with g of x. I'm going to FOIL. My firsts are 5x times 5x, which is 25x squared. My outers are 5x times the minus 1, which is a minus 5x. My inners are minus 1 times 5x, which is another minus 5x. My lasts are minus 1 times minus 1, which is a plus 1. We'll bring down the plus 2. I'm not going to commit to saying this is the answer because what I get here might factor, but I don't think it's going to factor. So this is 25x squared minus 10x. These terms don't cancel because the x's both have negative 5s in front of them. I add the negative 5s, keep them negative, and the last is a plus 3. That's a start. Before I forget, the domain answer for part B is something that means all real numbers because I don't see a square root, I don't see a fraction, so I don't have any algebra to do for my domain. I'm going to see if I can factor this. I don't think it will. This is why I'm doing this on another sheet of paper. This is my attempt of factoring 25x squared minus 10x plus 3. I'm going to use bottoms up. I'm going to multiply the 25 and the 3 and get x squared minus 10x plus 75. I know that if this factored, my signs would be minus and minus, which means I need factors of 75 that really add to, I need numbers that multiply to 75, add to minus 10. The numbers that multiply to 75 are 1 and 75. I could say negative 1 and negative 75 because that way I'd be adding to a negative number. Both the negatives and the parentheses tell me that the numbers are both going to get negatives there because I need to multiply to a positive and add to a negative, and so I need two negatives. Also, negative 3 times negative 25 multiplies to be 75, doesn't add to negative 10, they're not good. Negative 15 and negative 5 would be another set, and that set almost looks like it's the right set because I see a 10 there, but in order to get a 10, you'd have to have one positive and one negative. So if you said, oh, that factors into x plus 5 times x minus 15, you'd be wrong. When you foiled this out, you would get an x squared, you would get a minus 10x, but you'd get a minus 75 and not a plus 75. So although those numbers can give you a minus 10, they only give you a minus 10 if one is positive and one is negative. And if one is positive and one is negative, then this whole thing doesn't multiply out to be exactly the original problem. You have 2/3 of the original problem, but the wrong sign on the 75. So in order for me to factor, both the numbers have to have the same signs, and they're both going to be minuses, essentially. And because all the factors, there are no factors of 75 that work, this is prime. There's no common factor, so I'm going to commit to saying that's my answer to part 4A. But had it factored, I should factor. On a test, if you forget the factoring part and something you can factor, I won't hit you with a big penalty, but you'd lose a point for not simplifying, I'm sure. All right, for C and D, still in the world of polynomials, so I won't have to worry about the domain. The domain's going to be all real numbers until I start seeing either fractions or square roots. To do part C, I write the g function, which is 5x minus 1, without the x. I leave a parenthesis where the x is. Inside the parentheses, I put the right side of the f function. So it's always in this composition, whatever letter is written first, to the left of the composition symbol, you write that function without its x, leave a parenthesis where the x was. Inside the parentheses, whatever letter is written second, you write the right side of the letter that's written second. This I also think is not going to factor. It's only going to be a binomial. And for binomials with squares, the only way it can factor if it's a difference of squares or if there's a common factor. So I cleared the parentheses. I'm going to get 5x squared plus 10. I started writing minus 9 because I subtracted the 10 and 1 in my head, and I forgot, and I made it back into a 1. So this scratching was because I started doing the work of 10 minus 1 in my head. So I'm going to get g composed with f of x equals, I'm going to make that 10 minus 1 into a 9. This is going to be 5x squared minus 9. That doesn't factor. If this 5 was a number like 25 or 16 or 49, if that 5 had a square root, was a square rootable number, a number that's a perfect square, I could have factored this into two parentheses. Like if this was 16x squared minus 9, I would have factored it into 4x plus 3 times 4x minus 3. But because this 5 isn't a square, I can't do that kind of factoring, and there's no common factoring. There's no common factor, so that's all I can do. That's the answer to part C. And for D, again, because f, g, and the answer g composed with f of x are all polynomials, there's no algebra to find the domain. It's just all real numbers. Something that means all real numbers. And I like writing negative infinity to infinity. Actually, I like writing that, which means all real numbers as well. But I hadn't really been using that symbol this semester, so I didn't feel like bringing it back. But yeah, had you written that for the answer for the domain, I'd completely content with that as well. All right, still another polynomial. 6 asks me to find, again, f composed with g, g composed with f, the domain of each. To do f composed with g, that's going to be the easy part of this. I write the f function, which is x minus 3. Without the x, I leave a parenthesis where this x was. Inside the parentheses, I write the right side of the g function, which is x squared minus 4x minus 2. And then I just simplify. I don't take the work and set it equal to 0. So I'm going to get x squared minus 4x minus 2 minus 3. I can just drop that parentheses without changing the x squared, the minus 4x, or the minus 2, because there isn't a multiplication, a negative, or an exponent associated with that parentheses. The minus 2 and minus 3 have the same sign, so I'm going to add those numbers and keep them negative. And I'm going to get x squared minus 4x minus 5. That actually factors. And so in my answer, I should factor that, but I should not set the factors equal to 0. So in my answers, I'm going to say f composed with g of x equals, and this factors into x plus 1 times x minus 5. And again, no algebra for the domain, because f, g, and the answer are all polynomials. The domain is negative to positive infinity. The first 6 problems in this grouping are nice. Once we get to the fractions, the problems get pretty intense. The domain, it has a little twist to it in composition of functions that regular fraction domain problems don't have. And the algebra is messy too, so get prepared when we get out of this bank of problems for really some unpleasantry. So if you're in the habit of fast forwarding through some of my work, I wouldn't fast forward past number 8. Once the problems have fractions, they get messy. I'm not even sure I gave myself enough room there. 6c, g composed with f. I write the g function, x squared minus 4x minus 2, without both of the x's, so I left a blank parentheses squared and a minus of 4 times the parentheses because the g function had 2 x's. Inside each of the parentheses, I put an x minus 3. And then if I'm simplifying this, I generally don't keep writing the problem down on the left-hand side. Usually I would just write an equal sign. And that equal sign, if I don't write anything to the left of it, means the left-hand side doesn't change. And that's customary, rather than having to write that left-hand side that doesn't change over and over again for a problem that has a bunch of steps. Gets tedious to do. Carrying the equal sign down without writing anything to the left of it means that stuff stays the same. So I expanded the x minus 3, so I did my foiling. Now I can do my foiling. Firsts are x squared, outers are x times minus 3, which is a minus 3x, inners are minus 3 times x, which is a minus 3x, last minus 3 times minus 3 plus 9. Clear the next parentheses, be careful with the sign. Minus 4 times x is minus 4x. Minus 4 times minus 3 is positive 12. That's easy to miss the sign change on that. Minus 3, because minus 4 times minus 3 is a positive 12. And I take the minus 2. Now I'm going to combine like terms. The like terms are minus 3x, and minus 4x, and plus 9, plus 12, and minus 2. The x squared needs to hang out. It's not going to disappear, but it doesn't change when I'm going from this line to the next line. Here, I go minus 3, and minus 4. That's going to be minus 10. and the x doesn't change when I'm combining like that. And then 9 plus 12 is 21, minus 2 is a positive 19. That I'm pretty sure is prime. 19 is a prime number, so if I tried to factor this, I'd make two parentheses. I'd need to turn a 19 into a 10. I don't see any way to do that, so I'm not going to even take the time to attempt to factor that. If you attempt to factor that, you don't need bottoms up because there's not a number in front of the x squared. And you'll find, because the 19 being prime, there aren't a lot of possibilities of lasts, and there aren't any lasts that will work. The last easy domain, the domains here is still negative to positive infinity, because the original two problems, the f and the g function, along with the answers, are all polynomials. The domain is all real numbers, or negative to positive infinity, or something that means all real numbers. So be prepared now for your life to get quite a bit harder. The domain and these fraction problems is tricky, and the algebra is tricky. So this really does mean f composed with g of x. When I go to do the domain, there's going to be two levels of issues here. I can't put a value, there's going to be essentially two numbers to exclude from the domain. Any number that would make g undefined, if I put that number in, I'd get f of undefined, and that wouldn't be good. So to find the domain, first, because it's a domain, because it's a fraction, my answer is going to be the domain is all real numbers except, and it's the except part that gets a little bit confusing. There's going to be two exceptions. The first thing I'm going to do is that the number that's to the right of the circle, I'm going to find the domain of that particular function. So I'm going to find the domain of the g of x function, which is 1 over x plus 1. To find the domain of that function, you ignore the numerator, you set the denominator equal to 0. That tells me I need to have a negative 1 as part of the exception. So that's the first part of finding the domain for number 8. Because if I plug negative 1 in, if I did f composed with g of negative 1, the first thing I would technically do is find g of negative 1 and then plug that number into f, and g of negative 1 is undefined, so that would give me undefined. So that's the first part of finding the domain of a composition when it's a fraction. The function that's written to the right of the circle, you find its domain when there's algebra necessary. When the domains of everything is all real numbers, then it's not an issue. And now I'm actually going to find the function and find the number to exclude from the answer here, and that's going to also be part of my except. So there's actually going to be an except and then a comma. So to do f composed with g of x, I'm going to find out what the function is. I write the f function without the x, which is 1 over x minus 6. Leave a parentheses where the x was. Inside the parentheses, I write the g function. This is where the algebra is really tedious, but you need to get good at it because there's a handful of problems like this, and this kind of grunge comes up in calculus way more than I care for it to come up. So being good at this sort of manipulation is going to be important if you're going higher. So I'm going to work on that denominator. The denominator is 1 over x plus 1 minus 6. And what I'm going to do with the 6, instead of writing it as just 6, I'm going to write it as 6 over 1. And then I'm going to multiply the 6 by x plus 1 over x plus 1. And what that's going to do for me, it's going to give me f composed with g of x, I don't need to keep writing that, equals 1 over, and then 1 over x plus 1 minus, and then I'll go 6 times x is 6x, and 6 times 1 is plus 6 over x plus 1. So I've taken the denominator that has a fraction minus 6 made both pieces of the denominator have the same denominator. So I can combine those. So now I'm going to get f composed with g of x equals, that 1 up in the numerator, that's not a problem. Now in the denominator, I'm going to make this 1 minus 6x minus 6 over x plus 1. That's combining these two fractions together. When I'm allowed to subtract those two fractions because they have the same denominator. And when I subtract them, this minus sign impacts that 6 and changes that plus to a minus. I'm going to combine this minus 6 and positive 1 and write this as f composed with g of x equals 1 over, and this is going to be minus 6x minus 5 over x plus 1. Still more grunge to go. This stacked fraction is ugly. I'm going to rewrite this. I'm not going to bring this down, although I should bring it down. This is going to equal, I could write it, instead of writing it as a fraction, I could write it as a division. So this is going to be 1 divided by, which is that numerator, divided by negative 6x minus 5 over x plus 1. If I'm dividing by a fraction, I can invert and multiply. So this is going to be 1 times x plus 1 over negative 6x minus 5. 1 times anything is itself. This is basically the answer here of what f composed with g of x is. I'm going to factor out a negative from the denominator. And this is one version of the answer for part A that is suitable. So I can say f composed with g of x equals, and then x plus 1 over negative, factoring a negative out from there, and then 6x plus 5. I think I'm just going to stop right there. You could put that negative and write it in front of the fraction, but it's not necessary. So that's the algebra to find f composed with g of x. The algebra to find the domain first was finding the number to exclude from the function to the right of the circle. Now I'm going to find the domain of this by setting the denominator equal to 0. And I'm just going to set that equal to 0, which is easier for me to do than setting that equal to 0, and those are equal to each other. So the other number to exclude, I take the denominator in my answer, or in the step before my answer, because that's easier for me. And I'm going to add 5 and divide by 6. And I get negative 5 over negative 6 to exclude. And 5 over negative 6, you can move the negative up to the numerator and have it look more ordinary. And I need to also exclude that. So the domain in part B is going to be all real numbers except negative 1 and negative 5, 6. So in composition of functions, when both pieces are fractions, the domain should probably have 2 numbers to exclude from the all real numbers. Okay, that's a mess. 8b is going to be equivalently messy. Not any easier, not any harder, just equivalent. It wants me to do g composed with f of x. Same deal. When I go to find the domain, because this really means g of f of x, the first part of my domain, I'm going to get the number to exclude from the domain by finding the number that needs to be excluded from the fraction to the right of the circle. And for this f function, the number that you'd get excluded from the domain is 6. I don't have to do the g function because the g function is going to get changed and never used. The f function will actually get used, and then the result of the f function goes in the g function. The g function will never be used in the form that it starts with, so I don't have to worry about finding that. And if I do exclude the negative 1, it would actually be wrong. So the starting out of my answer for the domain, I'm going to say the domain is all real numbers and then accept. And the first part of my accept is 6, and I'm going to get a second part. So let me do now g composed with f of x. To do g composed with f of x, I write the g function without the x, so the g function is 1 over x plus 1. I wrote it without the x, and inside, I left a parenthesis where the x was. Inside that parenthesis, I put the right side of the f function, which is 1 over x minus 6. Now I'm going to simplify. I'm going to write this as 1 over x minus 6 plus, I'm going to write the 1 as 1 over 1, and I'm going to multiply that 1 by x minus 6 over x minus 6. And that will give me g composed with f of x equals 1 over x minus 6 plus, in place of the 1, I'm going to write x minus 6 over x minus 6. Now in the denominator, those two fractions can be combined together. So I'm going to come up here and do this. G composed with f of x equals, I still have the 1 in the numerator. When I make these two fractions into 1, because the plus between the fractions, I don't have to worry about the signs. I'm going to write the two fractions, numerators, the 1 and the x minus 6, over 1x minus 6. Now I'm going to combine the 1 minus 6 in that numerator and get g composed with f of x equals 1 over this middle layer I'm going to write as x minus 5, and then over x minus 6. I'm going to rewrite that as a division without a fraction, so I'm going to rewrite that as 1 divided by x minus 5 over x minus 6. Now I'm going to invert and multiply. I get g composed with f of x equals 1 times x minus 6 over x minus 5. 1 times anything is itself. So the answer to part C, g composed with f of x, is just going to be x minus 6 over x minus 5. That's the end of part C. To finish up my domain, I need to find out if there's any numbers that need to be excluded from the domain because of the new denominator. And I take that denominator, x minus 5, set it equal to 0, and find out that I need to also exclude 5. So my domain I get in 2 layers. First, the function that's written to the right of the open circle or the composition symbol. I find the number to exclude from that function, do all the algebra to find g composed with f of x, and then find any number that needs to be excluded from the domain because the denominator of the, because it's a fraction. Messy. 10's not quite as messy because the g of x isn't as ugly, and 12 probably isn't quite as, 12 is a different kind of problem, so it won't it'd be different. So for 10a, to find f composed with g of x, I know that means to do f of g of x. When I go to do the domain, the first thing I need to do is look at the g function because it's written to the right of the composition symbol. I'm going to find the number to exclude from its domain. And the number I'm going to exclude is 0 because to find the domain of that particular fraction, I ignore the numerator, I set the denominator equal to 0, and that gives me 0 needs to be excluded from the domain, and I didn't have any extra algebra really to do to find that. So for those of you lucky enough to go on to calculus, although this isn't calculus remotely, this is certainly the kind of algebra drudgery that you're going to get in calculus. There's just really, really fine, precise, messy algebra that just fills a calculus course, and you really need to hone your algebra skills in this class so that when you make the step from algebra to calculus, that it's not like a step that you can't make. If you don't get your algebra skills at their sharpest, then when you go from this class to calculus, you're just going to bog down because you'll be trying to relearn your algebra and then on top of learning calculus, and that's too much for one semester. So having your algebra skills as performing as best as they ever can is what you're going to need to shoot for by the time you get out of this class. And if you need to take calculus, get your calculus class taken as close to this class as possible because you don't want to forget your algebra. So anyways, getting back to part A, doing f composed with g of x, I wrote the f function, 1 over x minus 5, without the x, left a parentheses where the x was. Inside that parentheses, I write the right side of the g function, which is 1 over x. Just like the last two steps, the denominator can be written to set it up to combine the 1 over x, the fraction. So I wrote the 5 as a fraction, wrote it as 5 over 1. I'm going to multiply it by x over x. This is going to give me f composed with g of x equals 1 over, the first fraction is going to be 1 over x, the second fraction is going to be 5x over x. Now I'm ready to make that denominator into a single fraction because both the fractions have the same denominator. So I can get f composed with g of x equals, the 1 up top stays, and then in the denominator I'm going to write 1 minus 5x over x. If it bugs you, you could write minus 5x plus 1 as opposed to 1 minus 5x. And if you write minus 5x plus 1, you should probably factor out a negative. I'm going to leave it like this temporarily. I'm going to change the problem into its division form. So I'm going to write this as 1 divided by 1 minus 5x over x. Now I'm going to invert and multiply. So it'll be 1 times x over 1 minus 5x. 1 times anything is itself. This would be an acceptable answer. If you wrote f composed with g of x equals to x over 1 minus 5x, that would be acceptable. Anything else you would be doing to this would be just to make that denominator look more like you like to see it. So if you rewrote the denominator as negative 5x plus 1, that would be an okay answer next to the f composed with g of x. And if you did that and then you factored out a negative and did negative times 5x minus 1, that would be an acceptable answer. And if you did that and you move the negative up to the numerator, that would also be okay. So there are a variety of answers that are all equal to this, that are all okay. That's going to be another hang-up in calculus. In calculus, there's a lot of times where you do more steps than this to get to an answer. Your answer's correct, and when you check it to the author's answer, it looks different. And it's really disheartening because sometimes it's almost impossible to get your answer to look like the author's, yet your answer is right. There's different forms of the same answer that don't even look remotely the same, which is bites in some sense. To finish up part B, to find the domain of this, I take the denominator of the answer and set it equal to 0 to get my next number to exclude. So I'm going to go 1 minus 5x equal to 0. I'm going to add 5x to both sides and get 1 equals to 5x. Divide both sides by 5 and get 1/5 equals to x. The other number I'm going to exclude from my domain is the 1/5. And again, it would be wrong if I took the x minus 5 and set it equal to 0. You only take the function to the right of the composition and set it, find the number needs to be excluded from the domain because of it. So that's the first 10 problems. The fraction ones are infinitely more complicated than the non-fraction ones for both parts A and part B. The next few problems, the instructions say, show that G composed, oh no, I'm sorry, 10 is still another one of these problems. I haven't done C and D on number 10 yet. Once I get to 12, then it's a new style of problem. To do C, which is still not done with problem 10, this is g of f of x. I find the number to exclude from the domain from the f of x function. And I do that by taking the denominator and set it in equal to 0. And that tells me to exclude 5. So when I go to write the answer for part D, I give the domain as all real numbers. Because for all fractions, generally, my domain answer looks like this. And then after the word except, I write the number 5, leave myself room to write another number next to this that I get from setting the answer's denominator equal to 0. So to do this g composed with f of x, I write the g function, which is 1 over x, without the x. I leave a parenthesis where the x was, so this right here is just this 1 over x written without the x. Inside the parentheses, I write the right-hand side of the f function, which is 1 over x minus 5. And I simplify this. This is way easier to simplify because this is there aren't two pieces in the denominator that need to be made into one. I could immediately write this in its division form. This is going to be 1 divided by 1 over x minus 5. Now I'm going to invert and multiply, so this is going to be 1 times x minus 5 over 1. And this is really just 1 times x minus 5, because x minus 5 over 1 is just x minus 5. And that is just x minus 5. So the answer to part C isn't even going to be a fraction. G composed with f of x is just x minus 5, or x minus 5 over 1. So this is the answer to part C. And surprisingly, because this isn't a fraction, I don't have another number to accept, and there's only one number to exclude from the domain. So it's going to be all real numbers except 5. I would, if this was a fraction, get another number to exclude, but because this is a polynomial and its domain is all real numbers, then I don't have any more numbers to exclude. And make sure you can see that. Okay, so that's the first style of problem in this section. That's the hard style of problem. The next group of problems give me two functions, f and g again, and they ask me to show a, f composed with g of x is x, and b, g composed with f of x is x. So part A says find f composed with g of x, and it better equal x is what this says. And I can do this in one big line here. Usually when you're asked to show that f composed with g of x is x, you do that in one line. So to find f composed with g of x, I write the f function. Notice I'm not doing anything with domains, so I'm not asked to find a domain. I could, but since it's not asking me to do anything about a domain, I'm not going to do that. That's just more work that I don't have to do. So I'm going to write the f function, which is 3 minus 4x. I write the f function without the x, leave a parenthesis where the x was. Inside the parentheses, I put the right side of the g function, which is 3 minus x over 4. And in this problem, that 4 and that 4 is going to cancel. And when I cancel them, I'm left with 3 minus, and then the 3 minus x I can leave in a parenthesis temporarily, but the fraction's going to be gone. And didn't have enough room to get the whole answer in one line, so I'm just going to start writing equal signs. This is going to be 3 minus, I'm going to clear the parentheses, the minus is going to attach to that 3, and the double minus is going to make that x a plus. The 3's will cancel and I get an x. That's all. I'm done. There's no work, there's no answer in some sense. The problem said show that f composed with g of x is x, so I did that. I found f composed with g of x, and I got x for an answer, and that's all that I was instructed to do. It just said, find what f composed with g of x is, prove to me that it's x, and that's what I did. And for all these next problems, when I do the composition that's asked of, it needs to come out to be x. This is a kind of check to see that you can do compositions correct, as much as anything at this point. Part B of number 12 wants me to show that g composed with f of x is x. So I'll do that. I'm going to find g composed with f of x. To do that, I take the g function, I write it without the x, put a parenthesis where the x was. So that's the g function written without the x. There's where the x was. Inside that parentheses, I'm going to put the right side of the x function, which is 3 minus 4x. Now I'm going to get rid of that parentheses that I imposed. I'm going to change the 3 to a minus 3, the 4x to a positive 4x, because the minus in front of the parentheses just changes the signs of both of those. The 3's in the numerator are going to cancel, so I'm going to be left with 4x over 4, and those 4's will cancel. I don't have a fraction anymore because I've canceled the entire denominator. I can write just plain ordinary x. That's exactly what I was asked to show in problem 12. I was just find g composed with f of x, show me that the answer is x, and I'm done. There's nothing more to do than that. There's nothing to do with that x. You're just done when you do that. 14 is going to be obviously harder because of the fractions. It's an odd problem at that. Show that g composed with f composed with g of x is x. I'm going to go f composed with g of x. First thing I do is write the f function, which is 1 over x. I write the f function without the x. I leave a parenthesis where the x was. Seems like this is a mistake, but it's not. I want the f and the g function to be the same. So inside the parentheses, I'm going to put the right-hand side of the g function. Now I'm going to simplify this. I'm going to write it as a division problem rather than a fraction by writing 1 divided by 1 over x. Now I'm going to invert and multiply. This is going to be 1 times x over 1. That's just inverting and multiplying. That's just 1 times x. 1 times x is just x. So that's all problem 14a wanted me to do. It wanted me to show that f composed with g of x is x, and that's what I did. The next one's almost silly to do, to show that g composed with f of x is x, because exact same thing. To do g composed with f of x, I write the g function, which is 1 over x, without the x. So that's what I just did. I wrote the g function without the x, left a parenthesis where the x was. Inside the parentheses, I write the right-hand side of the f function, which is 1 over x. So it'll be exactly the same algebra. So I can write this as 1 divided by 1 over x. Invert and multiply this as 1 times x over 1, which is 1 times x, which is just x. Exactly. The 14a and 14b are identical lines, other than the very first thing says g composed with f as opposed to f composed with g. Other than that, those are identical problems. Next one's a mess, I think. To do 16a, to show that f composed with g of x is x, that's not going to be fun. So I'm going to go f composed with g of x, and I'm going to take the f function, which is x plus 3 over x minus 2. I'm going to write it without the x. I left a parenthesis where each x was, and inside the parentheses, I'm going to write 2x plus 3 over x minus 1 and 2x plus 3 over x minus 1. Bad things here. I can't just go to the right. I'm going to go down on this one. So I'm going to say this equals to 2x plus 3 over x minus 1 plus, and I'm going to write that 3 as 3 over 1, divided by 2x plus 3 over x minus 1 minus, and I'm going to write this as 2 over 1. So I'm prepping myself to get get the numerator and the denominator of this messy fraction simplified. I'm going to multiply the 3 by x minus 1 over x minus 1. I'm going to multiply the 2 by x minus 1 over x minus 1. And when I do that, I get 2x plus 3 over x minus 1 plus 3x minus 3 over x minus 1, because 1 times x minus 1 is x minus 1, over 2x plus 3 over x minus 1 minus, then I'm going to go 2 times x is 2x, 2 times minus 1 is minus 2 over x minus 1. Now I'm going to make these, the top and the bottom, into a single fraction by doing something like this. I'm going to go, this is going to be, in the numerator it's going to be, oh gosh, oh, I need another sheet of paper for this. So I'm going to rewrite what I have written right here. I have f composed with g of x equals to, and that fraction I'm going to combine together. I'm going to write 2x plus 3 plus 3x minus 1 over x minus 1 for that numerator. I wrote the 2x plus 3 and the 3x minus 1 next to each other without doing any sign changing. And then over, and then this 2x plus 3 is going to stay, but this minus is going to change this to a minus and that to a plus. It's going to change that sign. So in the denominator, I'm going to write 2x plus 3 minus 2x plus 2 over x minus 1. So I'm going to get 2x plus 3 minus 2x plus 2 over x minus 1. So I'm doing exactly what you need to do. If you do anything slightly different than this, you're doing something that's probably illegal. And you probably won't get exactly for an x for an answer. So now, in this numerator, I'm going to make the 2x and the 3x there into a 5x. I'm going to make this 3 minus 1 into a plus 2. And then in this denominator, 2x minus 2x is 0. Ooh, I'm worried. And 3 plus 2 is 5. So I just get 5. And I have a mistake somewhere. A mistake in one of multiple areas. Let me, before I go further, let me figure out what my mistake is and see. Oh my gosh, really? And see what the deal is here. So I'm going to do some side work that you can't see yet because it wouldn't be good for you to see. Works. So I have a mistake. So first of all, I knew I had a mistake because I was getting to this point right here, and I was going to invert and multiply. I'm going to get 5x plus 2 over x minus 1 times x minus 1 over 5. I was going to cancel the x minus 1s. I'm going to have 5x plus 2 over 5. That's not equal to x. That's not a good thing because f composed with g of x is supposed to equal x. And I did some algebra here that I didn't let you see. And you're not responsible for that yet. And I have a mistake. So now I need to track down my mistake. There's one of two things I do. Either A, I look at my work and try to find my mistake, or B, I start the problem over. So for a brief second, I'm going to see if I can find my mistake. Hopefully it's obvious to me, and I see one already. And if that's the case, then good things could happen. Immediately, as I just open this sheet up, I look at this 3x minus 1 right here, and I did 3 times x, and I forgot to do the 3 times 1. This right here should be 3x minus 3. I believe that's the only mistake I had, and that minor mistake is going to, fixing that minor mistake, so changing the 3x minus 1 to a 3x minus 3 on this sheet, fixing that minor mistake is going to fix my whole issue. So the work that I did after I made that mistake, all this work, because there's a mistake above it, it's wrong. And I'm not going to look at this anymore. I'm going to fix this minus 1, which is 3x minus 1, and change it to 3x minus 3. And now see if that fix takes me to where I need to be taken. So now I'm going to get f composed with g of x. It's actually not bad that I made this mistake because it's something that you're very likely could do by yourself. And when you make a mistake, you just need to hunt it out and then just fix. So I found my mistake. Hopefully there was only one mistake. I found my mistake, and then everything after that mistake that I did is wrong. But this very first line that I did after this mistake, I did so little algebra, I just made those two fractions together. I could put that mistake fixed there, And now I'm going to get back to this. So I'm going to simplify this numerator here. 2x plus 3x is 5x. 3 minus 3, those cancel. So this numerator here simplifies to be 5x over x minus 1. This denominator down here, the 2x minus 2x is cancel, and the 3 and the 2 give me 5. So this is going to give me 5 over x minus 1. So now I have 5x over x minus 1 times divided by 5 over x minus 1. I'm going to write this in its division form. This is going to be 5x over x minus 1 divided by 5 over x minus 1. I'm going to invert and multiply and get 5x over x minus 1 times x minus 1 over 5. The x minus 1s are going to cancel. The 5s are going to cancel. The only thing that doesn't cancel is an x. It's in the numerator, and that was my goal. My goal was to show that f composed with g of x was x. Took me 2 sheets of paper to do it, and that's not going to be uncommon in calculus. And it took me 1, 2, 3, 4, 5, 6, 7 steps to get there, and each of the steps was kind of a multiple step process. So maybe it's more like 9 steps to get there, or 10 steps to get there, and pretty confusing steps for that matter. So at this point in your algebra career, you shouldn't be able to do this like if somebody says, here, do this, and never have shown you an example. I wouldn't expect you to be able to do it without ever being shown an example. But after I do a couple, 2, 3, or 4 examples, then you should start to have the ability to reproduce this yourself. You might, as you're going to reproduce this, need to have my work right in front of you, and you might need to just mimic my work, which is completely fine until you do enough of these that you get good at them. That was a mess. I knew 16a would be a mess. 16b is equivalently going to be an equivalent mess. It might even be slightly messier, if that's possible, but I think it could be. So 16b, essentially the same thing. I show that g composed of f of x equals x. So I'm going to do that. I'm going to find g composed with f of x. To do that, I write the g function, which is 2x plus 3 times x minus 1. I wrote the g function without the x, left parentheses where the x's were. Inside the parentheses, I write the right side of the f function, which is x plus 3 over x minus 2. So in each of my parentheses, I'm putting an x plus 3 times an x minus 2. And now I'm going to simplify. In the numerator, this 2 can be multiplied by the x and the 3. And I'm going to get, didn't leave myself enough room there. I get this. I get 2x plus 6 over x minus 2 plus 3. I'm going to write the 3 as 3 over 1 divided by x plus 3 over x minus 2 minus, I'm going to write the 1 as 1 over 1. Now I'm going to combine the numerators and the denominators a little bit better. I'm going to multiply the 3 by x minus 2 over x minus 2 and the 1 over 1 by x minus 2 over x minus 2. And when I do this, I get 2x plus 6 over x minus 2 plus 3x minus 6 over x minus 2 divided by x plus 3 over x minus 2 minus, and then 1 times anything is itself, so this is going to be x minus 2 over x minus 2. So now I have both the numerator and the denominator written with 2 fractions with the same denominator. I'm going to combine the fractions, the 2 fractions in the numerator to 1 fraction, the 2 fractions in the denominator to 1 fraction. The minus in the denominator is going to change that sign to minus and that sign to plus when I make the 2 fractions into 1. So, new sheet of paper because I can't fit this here. When I do my fractions, I'm going to get, I should write probably g composed with f of x equals, and then I'm going to get 2x plus 6 plus 3x minus 6 over x minus 2 for making the two fractions in the numerator together, and then x plus 3 minus x plus 2 over x minus 2 by taking the two fractions in the denominator. So I wrote those two numerators together, these two numerators together, but the minus sign between the two caused me to make it a minus x and a plus 2. Now that I have that done, in the numerator, the 2x and the 3x add up to 5x, the 6's cancel, so I get 5x over x minus 2 divided by, in the denominator, the x's cancel, the 3 and the 2 come out to be 5, so that's 5 over x minus 2. Now I write this in its division form. This is 5x over x minus 2 divided by 5 over x minus 2. Invert and multiply. This is 5x over x minus 2 times x minus 2 over 5. Cancel the x minus 2's, cancel the 5's. I'm left with an x only. It's in the numerator. I don't have a fraction anymore. This whole thing equals x just like it's supposed to. So it was a short section in terms of there's only 16 problems in the section, but each of the problems had at least a part A and a part B, or A, B, C, and D. So really the section in hiding, had more like 30 or 40 problems, which is kind of what I like a section to have. And it's kind of messy, to say the least. So there's a lot of grunge in here. So before you move on to the next section, make sure you have this section, kind of understood really well, because some of this composition stuff is going to come up again. And if you don't quite have it under control, then the next section might not go as nicely as it should.